I have the absolute pleasure of sitting down with Dr. Andrew Marino, who is kind of a legend within the electrobiology space and was, working with Dr. Robert O Becker back in the day. And I'm really, really excited to unpack, Andrew's work, but also the work that he was exposed to in Becker's lab, and also how his career progressed over time, because he ended up going to law school and getting his JD as well. So I'm really, really excited to hear how he unpacks that story with us. But I mean, for now, I'd just love to introduce you onto the podcast, and thank you so much for coming on.
Okay, glad to be here.
Yeah, it's going to be really fun. I mean, I think a good place to start is, you've gone through and done so much in your career, but if you want to give just maybe a couple minutes introduction of how you would encapsulate like who you are as a scientist, what have been your main focuses, and then we can kind of get into some of the details surrounding what you've described in your book, Going Somewhere, which I recommend everybody read, and we can get into some of the science in there.
Well, I started out the undergraduate degree in physics, and then went to work for a year and a half in industry. My first introduction to technology involving electromagnetic energy. I worked on magnetohydrodynamic studies and on lasers, using them as distance finders, and quickly saw that the guys who had PhDs had all the fun. So I went back to school and got my PhD in physics. And while I was there, I had the good fortune to meet Dr. Becker, and my life spun off in the direction that he had plotted for himself. I started walking down the same road with him, and then when he retired, I kept on walking.
Mm-hmm. Yeah, so he was at Syracuse, right? Is that where you did your PhD?
Yes, did my PhD at Syracuse, and his lab was at that time very well funded, nationally funded, across the street in the Veterans Administration Hospital. So I went down the steps across the street, up 9 floors, and I was in a beautiful lab with a guy who was the most brilliant guy I ever met, one of the premier scientists of the last century, as far as I'm concerned, and everything worked out from there.
Yeah, so I mean, for those who don't know, and you can correct me if I'm wrong, but my understanding is that when Dr. Becker was in medical school, he had this speech that was being given by Dr. Albert St. Georgi, who was a Nobel Prize winner, that he was talking about how he thought it was interesting that it seemed like there was an electronic structure encoded by the genome. So basically all proteins were semiconductors at some level, and that inspired Becker to go down this route of studying, whether this is true or not. And then also getting into the role of EMFs or ELFs or whatever we want to call them, like non-native EMFs or extremely low frequency electromagnetic fields that could be impacting biology in a meaningful way. And so that's what he was studying when you joined the lab. That's right.
I couldn't have summed it up better. Everything you said was spot on. He admired St. Georgi. He took St. Georgi's teaching. St. Georgi was a biochemist who was self-taught in biophysics. I'll put it that way. He had no background, as no biologist ever has in physics. It's almost illegal for them to learn about physics. But St. Georgi taught himself about physics, came up with this idea of a solid state semiconductor properties. It appealed to Becker, because Becker was he was trained as a physician, so he knew about biochemistry, but he regarded it as, his word for it was stamp collecting. It's trivial, really. I mean, if something happens in the body, it's got to be mediated by a biochemical mechanism. It can't be the finger of God, Marino, he used to say to me. It's biochemistry. But the salient question is, what controls it? How is it controlled? Now, biochemistry takes a walk on that issue, and that day and to this day has still kept on walking away from that issue. So he needed somebody from physics to help him. We can go into that story later. I was fortunate enough to get the job, and I spent my my whole time getting my PhD. My research was done in his lab, trying to sustain that very insight, the idea that it's a semiconductor? Well, it turns out the electrical energy that's conducted in the body isn't conducted by electrons. It's conducted by ions in an aqueous environment. And I, after 3.5 years, finishing my doctorate work, had the undesirable responsibility to tell that to Dr. Becker. Scared like hell about what was going to happen. But good things happened. He took it like a man.
That's good. I mean, that's a mark of a good scientist as well.
Absolutely. Going back to your original point, your original question, he started off with this profound respect for St. George. And then, unfortunately, I met St. George, had dinner with him, had a good conversation with him. And when I got back, Becker said, "Did he know anything about my work?" I said, "No. He never heard of you, Dr. Becker."
Aww.
I kept delivering him bad news, but he kept on supporting me.
Wow. Wait, so did you have dinner with St. George while you were a PhD student, or was that after?
Oh no. I was well into this. This is now in the 1978, 1979. I realized that this bioelectricity is not going away, and I was right. There is something to it. Well, I started a journal, and the people who were participating in organizing the journal put together a dinner, invited St. George and several of us who were involved in the journal. And that's when I met him.
Wow. How old was he at the time, roughly?
Old. He didn't last much longer, but not senile. And old enough to have a daughter as young and as pretty as you are. Can you imagine at his age?
Wow.
Sitting right there beside him.
Wow. Wait, did he have like a wife who was much younger than him?
Yes, the woman sitting right beside him.
Oh, that was the wife, not the daughter.
No, it was the girl. Okay, I can't say for sure they were married.
Okay,
they acted like it.
Wow, that's interesting. Good for him.
Yeah. So he must know something about biology.
Oh my gosh, that's great. So yeah, I mean, he won the Nobel Prize back in like what year was it? The
30s.
40s, 40s, 30s?
30s, yeah.
30s. Yeah.
Nothing to do with this. It had to do with vitamin
C, I think.
Vitamin C.
Yeah.
Right.
Yeah, wow.
He got so involved in electromagnetic energy. And when I talked to him, I said, why did you do that? Why did you cross over where you were a really big shot to someplace where there's going to be nothing but heartbreak because people are going to. So he looked at me. He was sitting right across the table from me, and he held his hands up like this, like he was balancing two rats, rat here and a rat here. That's what he said to me. Rat here, rat here. This one's alive. This one's dead. What's the difference? It's not biochemistry. What's left? The only other force in nature that's possible, electromagnetic forces. That he went into that. That was his explanation to me for what got him going down that road.
Wow. So another really curious mind and a good scientific mind.
Absolutely.
That's incredible. So when you joined Becker's lab, he was like in his heyday. He had a lot of funding coming in and like things were good.
He was in his heyday of his heydays. He was just starting. He started in 61, and through 62 to 64, go to his website. We prepared a website for him.
Oh, awesome.
You go there and you'll see he published 6 or 7 or 8 articles during that period of time that were seminal in every respect. And they were published in the world's most famous journals, Science and Nature, the journal of his profession, bone and joint surgery, the biggest journal there is, and that's it. All having to do with the role of electromagnetic energy in growth and healing. So now I get to see him here. This is in September of 64. He's got a lot of money. He's flush with money from the Veterans Administration. They have a celebrity to shortstop their national research program. The Academy, I mean, the National Institute of Health is telling Congress that they are going to bankroll new ideas, and there is not a better new idea in the country. So he had NIH grants. He had a lot of money. So now he can go beyond just having employees through the VA system. He can go out and hire people. So he goes across to the guy who was my mentor in my first year of graduate school and asks for a recommendation for a graduate student. The deal would be that I would get my degree from Syracuse University, but do my research guarded and guided by Becker in his lab right across the street from the physics department. And he had the money to pay me, and he paid me well. I got made a federal employee because I'm working for him. The grant money is coming to him. I'm making, if you can believe this, 5 times the stipend that I was getting as a graduate student.
Whoa!
It just so happened I was a research biophysicist, and the federal government had a premium to get research biophysicists on board. They're fighting like hell to catch up with the Russians, they're launching the satellite, all that business. So there I was, having the dream job in the world, more money than I could ever imagine as starting my second year as graduate student, having the opportunity, listening to Dr. Becker, to change the world. I mean, his research was incredible. That's how it started.
Wow, that does sound like the dream. I mean, when I was in grad school, and I mean, it's still kind of like that, though they did increase the stipend slightly after I left, mostly because of inflation, though. But Princeton's a really expensive area. I'm still here. The stipend was like $3,000 a month, barely enough to cover like food, housing, and then like you're getting worked crazy hours. So like I can imagine working under somebody so prestigious and has with so much integrity, and then also getting paid on top of that. Like that is the dream for sure.
Back then, when I was getting it, there was $4,000 a year and free tuition. Okay, and my salary quadrupled. Just like that.
That's amazing.
So you can see I'm walking on clouds. He offered me the job after explaining to me his research. 4 or 5 other guys had gone there for the interview and didn't get an offer, but I wasn't expecting one. But we hit it off right away. I mean, he liked me and I liked him, and I was in a trance. But I heard the word, "Would you like the job?" And before the air molecules stopped vibrating, they carried job to my ear. I said yes. I mean, I couldn't say it fast enough, and I started. I couldn't take the job right away because I already had a job as a summer student at Langley at NASA. But when that ended, I came back and started and stayed with him for 5 years. I got my PhD, 4 years, right, with him, 5 years for me to get the degree, and then I stayed with him for another 12 years because he wanted me to stay. And then bad things happened and he was gone.
Yeah, I definitely want to make sure. At 50, he was 56?
Yeah.
Yeah, I definitely want to make sure that we talk about that, but maybe let's talk a little bit about like the science that led up to the point before he like got canceled, quote unquote. Because I think it's really interesting because it seems like the government and the military, they were like into what he was doing up to a point. I don't know if there wasn't a realization of the implications of the work, perhaps. But it seemed like they were excited to fund the research, and maybe we can talk about some of those studies that like you were involved in while you were there, and then leading up to like the results that you guys got that showed like actually, there are major implications to this research and to this data.
Okay.
Yeah, so maybe actually let's maybe just start when you joined the lab. What were some of the initial projects that you worked on and some of the initial findings?
His theory was that he had zoned in on what controls bone growth after a fracture. You break a bone, and you got dead bone at the ends of the broken bone. Cells come into the area. Something turns them on. And the cells start making, they begin getting rid of the dead bone at the very end, because that's got to go away. And then they begin secreting collagen, which is the framework for bone, and the collagen bridges the gap. And then calcium comes out of solution, the interstitial solution forms hydroxyapatite crystals, and the calcium in bone. And now you got a big bulbous thing of bone there. And you wait a couple of months, and that big bulbous thing gets modeled down to a beautiful straight bone. And you can't ever tell the lung was broken. Even if you take biopsies, it looks like bone anyplace else. Marino, what turns it on? What governs it? What controls it? What stops it? How does it know to make arm bone in the arm and leg bone in the leg? So he starts doing experiments, and he begins with a salamander because it's cheap. That's when he discovers that the salamander, which I might tell you is the animal that's highest on the phylogenetic scale that regenerates a limb. Cut off a limb, and unexpectedly, well, he read about it, he knew about it, but what happens is the animal grows a limb. Now, he takes a frog, which is the next step up phylogenetically, cuts off a limb of frog, and it doesn't grow. That's where regeneration of limbs, not just bone, the whole limb, the joint, the tendons, the muscles, and all the structures below, like the feet, for example, which have umpty bones in it, all come together in a certain way. What the hell makes that happen? I mean, he was just floored by it. It wasn't biochemistry. What controls it? Those were the early experiments that he published between 61 and 64. And now we're down to more. I'm a physicist. I have to design experiments that's going to pass my doctoral committee as physics. You see, I mean, I had to do things that supported his idea of electromagnetic energy being the undergirding mechanism that allows regeneration of bone and whole limbs in animals. Only bone in humans, just about the only tissue. One or two small exceptions. In human beings, it regenerates. Everything else heals by a much more inferior process. So I started doing physics-related experiments. With the money that we got, we bought an electromagnetic paramagnetic spectrometer. I mean, this thing cost $70,000 or $80,000, but he had the money. He bought it, and there I am. I mean, it's the equivalent of sitting in front of a cockpit to fly a spaceship. That's what I felt like. And I was looking for the detection of free radicals, electrons in the context of biological tissue, bone. So I put shaved bone, I put it in a quartz container, put that in a microwave cavity, did the resonance, and found out physical properties of this free radical. He was tickled to death. We published it in Nature. Everything is going great. I don't realize it at the time. I'm going up Fool's Hill because in biology, there's water. When you put the water in, you get no resonance. It's all gone. I mean, it's a whole other ball game. But at any rate, at that point, we're just feeling our way along. And I got we got publications, we got recognition, but I couldn't say I supported his hypothesis because it didn't carry over to living things. It's all dead stuff. Then another aspect is I tried to study water. All right, so I studied the dielectric constant of bone as a function of water content. So I put it in an environment, and it takes in water spontaneously, and I measure the amount of water, calibrating it in a way, but measuring the actual dependent variable is the parameter that codes for a dielectric constant. So I did the EPR, I did the dielectric constant measurements, and I did another measurement that not only didn't support him, it anti-supported him. it was an experiment done by Becker and a guy he worked with, an orthopedic surgeon, famous guy named Bassett at Columbia, famous guy. He takes collagen, which is the framework protein of bone, the thing that's laid down first at a healing site, and he puts it in a solution. You can do that, and then he passes very weak current through the solution. And his idea is that maybe, given the electrical definition of that unit, where the electric fields were, he was hoping that the fibrils would line up between the electrodes. And they did. They did. Whoa, it was terrific. Except he jumped too fast. He and the big shot from Columbia was pointing to this thing every speech they gave that supporting their theory. What I had was an electrochemical cell passing a current through a water environment. And when you put two electrodes in that, you get a cell, an electrochemical cell. Hydrogen gets generated at one electrode, oxygen gets generated at another. It dissolves in the solution. One part of the solution becomes acidic, one becomes basic. And don't you know that collagen spontaneously comes out of solution at a given basic pH? Mm-hmm. So the basic pH that was forming those bands, which you could see in a microscope. It was the damnedest thing. You could watch it through a microscope. You could see the bands form as the current is going through. Okay. But that can't happen in the body. There are no two wires passing a current. Something else is making a line, not that. And I had to go tell him that. It broke my heart. But like you said, he was a good scientist. He said, well, Marino, write it up and send it in, which is what I did. And he's a co-author. Now, he had done the original experiment with Bassett. And so I wrote Bassett. I said, listen, Andy Bassett, Andy, you're wrong about having a role in regulating bone growth for this and so reason. I wanted to invite him, like Becker, to be an author on the paper so as not to embarrass him. He refused. So he stopped maintaining it, but he refused. That told me that he wasn't one half the scientist Becker was.
Yep. He had a reputation or whatever. He thought that experiment was so important that he didn't want to. But it doesn't make a ton of sense, because where did you guys publish that paper? So, like, did he end up getting discredited at all? No, he just he no longer had to impress the editors of Science or Nature. He had to impress the investors in the startup company that he was. Okay, that makes sense. He had different incentives.
Yes.
Okay.
Wow. He became a founder of a company called Electrobiology, which by 1982, which is now less than 10 years, less than 7 years that the experiment I just described took place, he became an owner, along with an electrophysiologist, electrochemist, and the venture capitalist who put the money up in the company. By 1982, was the most profitable small business in the United States. Got the award for that. Wow. That's how fast an electromagnetic device that had potential clinical applications could be brought to the market.
Wow. And so did it work at all?
Yes, but not for any of the highbrow, classical, beautiful, wonderful theories they had. It works because anything that you do to bone will make it grow. You can hit it with a hammer. You can drop in acid. You can do anything to it, and it exhibits an osteogenic response, which goes on automatically. The energy they were putting in was no more than a trivial stimulus, like every other stimulus ever tried. I found articles in the 1930s where they did it by putting rusty nails in the bone. They put rusty nails in the bone and the bone grows.
Whoa.
Anything that upsets the balance triggers the response.
Okay.
So see, what was important for the FDA argument, the argument to FDA, was that this was something novel and new and special. At least that turned on the investors. After a while, I realized that FDA didn't give a damn. They just look, if you put it in people and it makes people grow bone, then you can sell it. That's their idea of science.
Mm-hmm. And they still don't give a damn.
It's the same idea.
Yeah.
It's the same, right. And the present standards for the safety of cell phones is a classic example.
Yes, and we're gonna definitely have to get into that before
Yeah,
we
I
do.
thought we
Before we
might.
do, though, I don't want to
Yeah,
get spoilers.
there's a little we got to connect dots, don't we?
Yeah, that's what I'm thinking. So I'm thinking around this time, at what point, I guess, in your time working with Becker, did he and you have the realization that like the electromagnetic frequencies in the environment that are like man-made, let's say, were influencing biology?
Ah, it started. It started with Dr. Becker's open-mindedness to the idea that the body was an electrically governed machine. So he was open to research that was in that direction. And he came across the work of Frank Brown. I can't go into detail about it, but he was a very excellent scientist working at Yale. And he presented categorical evidence that made it certain. The Jesuits who taught me would say metaphysically certain that the animals in nature can detect and use as a navigation aid the magneto-static field of the Earth. He paid a big price. He got thumped on big time, but that supported his developing notion about the importance of electromagnetic energy. He did a deep dive into the literature going back to the 40s and found another professor, I think also at Yale, who was measuring electrical signals on the surface of plants. I don't know if you realize it, but every living thing, if you take a voltmeter and connect 2 points of a voltmeter, a special voltmeter, not any one, it can't draw energy from the source. You got to use an electrometer that can draws no more than 10 to the minus 18th of an amp. But when you do that, you can find reliable measurements of voltage between those 2 points. Even a cheap meter will give you a measurement of voltage. The voltage won't be exact, but it'll tell you it's there. What's 2 points? Any 2 points. You walk out and stick them in a tree, you find it. You stick it between here and here in your arm, and you'll find it. That was some information to him that suggested that the body was generating this energy and was somehow using it for controlling itself. So he began doing experiments. He figured the energy probably passed along nerves, but it wasn't the nerve action potential. It was something completely different. So he starts making voltage measurements using the correct instrumentation on the surface of frogs and salamanders. And don't you know that the pattern showed, it reflected the anatomic pattern of the peripheral nerves underneath the skin. He's on top of the skin, making no injury. So this is all published between 61 and 64. You can see why he rose to astronomical heights and got published in the world's best journals. And it was, like I said before, then I came in trying to put his observations. They're all you might say anecdotal. They're not experimental in the sense of you have a controlled experiment. Well, in some sense they were, but not in the sense that a physicist would say a controlled experiment. And you're measuring something, and you know there's a causal relationship if the parameter being measured changes in the exposed, but not in the control. That basic design, what I call gold standard animal studies. He wasn't doing those kinds of studies. I started doing them. I started doing them after I gave him the bad news, but saw he was having success within orthopedics with regard to stimulating bone growth. And Bassett is already almost to the market. He's doing an FDA. He's close to doing an FDA study on humans, so he's already there. And I say, how do they know it's safe? That mattered to me. It does not matter to venture capitalists, and it does not matter to some people who have MDs. They'll do the bottom necessary to not cause acute effects, but they ain't going looking for a problem. That was their attitude. And Becker didn't have that attitude. So he commissioned me to do gold standard studies in animals. I would take a rat, I'd put from the same supplier, came the same day, the same genetic background. I'd put 20 in an electromagnetic environment, the one I just chose for simulation. The one I chose turns out to have governed the rest of my life, but I chose one. And then another group, housed, caged, and fed exactly the same, but no electromagnetic energy exposure. And then at the end of X days, I killed them and made these measurements, and I looked for a change in parameter 1, parameter 2, parameter 3. Now, if this electromagnetic field had no consequences, no effects, these parameters wouldn't change. But the parameters changed. Therefore, these electromagnetic fields had biological effects. They were biologically significant. They weren't as irrelevant to you as the color of your blouse. It had some meaning, and off I went. Becker started communicating this information to his superiors at VA because he had to, right? But also, by this time, nasty things are happening around the world, particularly in Moscow, for the American embassy there. And all of a sudden, in 66, 67, 68, I got my degree in 68, I see these guys, and I can never think of a better word for it than spooks. They look like spooks. They just a somber look. They had a mustache and glasses. Looked educated and dead serious. They would, from time to time, visit Dr. Becker in his office.
Oh gosh.
I didn't know why. I figured it out after a year or two that they were coming to him for advice. He never said a word to me. He was in the military. He had a military frame of mind. Let me say for the record, he was a conservative Republican in terms of his attitude, which I wasn't, but he was, and he still hired me. Again, just showing what kind of a guy he is. He wanted to do anything he could to serve his country. He was a patriot. I don't know other way to put it. And they required him to mention this to nobody, and he never did. I figured out a few things in my own way, but I never got confident. I never even broached the thing with him. I didn't have the chutzpah to do that, much less. So that's how it started with me getting into the EMFs might not be so good for you.
Mm-hmm. And when you did those studies with the rats, what were the frequencies that you were using? Were they similar to like electrical poles, or like what were they similar to that we could compare to?
Yes, they were similar to that.
Okay.
Why? Because in order to make a device, I built a device. The energy was right there at the wall. All I
Yeah.
needed was a transformer, a few switches, and a metal box, some metal plates to form a capacitor. I didn't connect to the animals. I applied it electrostatically through. I put them in the middle of a condenser, a plate here and a plate there, and everything was in between, including the animal and the box and the food and everything else. And so I used 60 hertz and exposed them with to an electric field. And then later experiments in which I went through a whole lot more trouble to make Helmholtz coils to create magnetic fields, and I did that much later, and had. Well, there's another story. Well, if we ever get to what happened in Shreveport after I moved there, after I left the Becker's lab, that's when I'll pick that one up.
Oh,
But anyway, I got into the anthropogenic effects of electromagnetic energy.
Got it. Got it. And so, for some context, back at this time, the primary sources of electromagnetic frequencies would have been like radio towers and like electrical lines
And radar, certainly.
and radar. Yes.
Well,
Yeah.
before the turn of the century, there was none. Then they built a power line in New York, which is about 4 or 5 blocks long. Then they started building transmission lines. Now, transmission lines are all over the country. Do a wonderful thing. God knows I don't want to be in a world without electricity. But they never stopped to think. They never stopped to think that the energy carried by these lines, say a 500,000 volt line, big wires. People think the energy is inside the wires. It ain't. It's around the wires. If you tried to put it in a wire this big, I mean, it would vaporize the wire. It's impossible. The energy is outside. It's a thing called a Poynting flux. It goes outside. So people who are living in even in the right of way, of course, they're exposed. But even outside the right of way, they're living in this flow constantly, day in and day out, year in and year out. Okay? No one ever stopped to think that this thing, which is something new in the history of the world, it had never existed before. All life evolved on Earth without being exposed to this, and now people are being exposed continuously to this forever. Right? Somebody should ask the question about whether it's safe. No one had any interest in asking that. The power company certainly didn't. There was no citizens' awareness because they had no idea that it was there, much less that they thought the energy was in the wire. And the power company made no effort to explain where the energy was. That was just no reason to publicize that. No good for their business could come from that.
Oh yeah. We can't expect those companies to do the research on the safety studies. They don't have an incentive to actually do like research with integrity in that space, let's say. So it makes perfect sense.
They have the opposite. They have the motivation to do rigged research, which is what they have done ever since they began attacking me. They began attacking me less than 1 year after I published my first papers.
Wow.
And it was never stopped.
Wow. Yeah, that's crazy. And I think as humans, we also can have a bias. If like we can't see something, then we feel like it's not hurting us. And it's like,
I don't certainly. How would a layman know about that? If you don't have a PhD in physics, how do you know about that? I mean, the lack of ethics, I'll call it, is the problem, and it rests with the industry. It's not ignorance that rests with the public. They have no responsibility to get a PhD. They have no responsibility to study physics at all. But they do have a right not to become victims like the blacks were in the Tuskegee study. That's wrong, and the wrongness of that just drove my whole life.
Yeah. And I think, we're going to get to when Becker got like canceled, let's say, but I think the fact that happened to him set us back so many decades health wise, because the way I really see it is like electromagnetic pollution is probably the biggest thing that we're facing right now from a societal standpoint with regards to our healthcare. And nobody's talking about it. And the people who do talk about it get discredited and like told that they're pseudoscientific. And it's really because we cut the science off in the 70s and then we never really picked it up. And there's some researchers that are dabbling, like Michael Levin is at Tufts and he's working in electrobiology. But even him, like, I went to the electrobiology conference and I asked him about the role of non-native EMFs in regulating, biology and like the electrical biology features that he's studying, and he wouldn't comment on it.
Mike Levin is a nice guy.
He seems like it, yeah.
I'll send you the correspondence I had with him 20 and 30 years ago.
Great.
But he has survived. He has continued to get money for funding.
Yeah.
Now I got one or two NIH grants, but it was political pressure that required them to not fund me. My success was entirely due to having the best job in the world between 1964 and 1980, working for Becker, who gave me complete authority over how to design my experiments and complete support for publishing the results, and raised all the money I needed. I got one NIH grant during that period, but politics drove it. Becker was getting it for other reasons. I had the best job in the world. Then I leave in between 1980 and 2014. I had the best job in the world that existed that whole time period. I had people who liked my work, supported my work, provided me the resources to do my work. From 1964 to 2014, actually to 2010, because by that time I become mostly self-supported. I never had less than $100,000 a year to spend on my research. So I was always able to keep my head above water, to keep publishing papers. I was not a big enough wrinkle in the propagating waves to alter the onset and propagation. It was inevitable, and that brought us to where we are today. But the record is there. I could hope for no more than to be happy, to have my own head, to publish my papers. That's the most I could, and to answer every question I set out in life to answer. It just doesn't get any better than that.
Totally. And I mean, I can totally also sympathize with Dr. Levin because he doesn't want to go through the same experience that Becker went through.
He didn't. There can only be one guy who gets the best job in the world during that period of time, and I had it.
You got it.
He had to survive. I like him a lot, but he started off with leads. Well, he started off as getting his PhD in the lab that was headed by a guy named Jaffe, who detested Becker and did everything he could to bring Becker down. And it was the main tool used by Philip Handler, who was then president of the National Academy of Sciences, in getting Becker's laboratory closed and sending Becker into retirement in 1980 at the age of 56. So I would not say that Mike's pedigree is the best, but I always liked him as an individual. I always thought he did the best with what he could, with the tools he had, and the environment he functioned. I have I have respect for him for that.
Yeah, I think that's warranted as well. So, I mean, we're kind of teased around the issue, but maybe let's start talking about the research that led up to Becker going on 60 Minutes and then what transpired afterwards.
Well, Becker, I don't know exactly how 60 Minutes heard about Becker. I just don't remember. But we got a call from Dan Rather, and he asked me some questions about Becker's work. And we skipped a big story in between that led to this. But Becker had taken a position publicly that a committee created by the Navy and appointed by Philip Handler to evaluate data. He had criticized the committee that Handler had appointed. So he went on 60 Minutes and Rather asked Dr. Becker if the committee that's involved, this committee opined that Navy-supported work involving a huge antenna indicated the antenna would be safe, and it was okay to build the antenna over 35 to 45% of the state of Wisconsin. No problem. He was asked by Rather, you can see the interview, it's posted.
Yeah, I'm going to link to it in the show notes. I watched it. It's profound.
He was asked if the committee that evaluated the Navy results the Academy committee that evaluated the Navy results. Becker was on the committee that evaluated the Navy results and said, listen, you guys had a problem, as did everybody else at that meeting. And that's when Becker learned about power lines, by the way. Anyway, let's fast forward to your question. Rather looks at Becker and says, are you saying the committee? Yeah, and I asked Handler's committee. He appointed every member of that committee. He appoints every member of every Academy committee. Is rigged? And Becker said yes. Handler, by the way, I'm now just finishing my book on Handler, so I want to give you a conflict of interest notice here that Handler, in my mind, is one of the nastiest human beings who ever lived, and particularly considered his power and authority he had. But I had no idea that he was worse than what I saw at that time. I've since gone back and read every one of the 116 testimonies before Congress he's given. I've read every article, if you call them articles. They're not articles in the scientific sense. They're opinion pieces he's read. All the letters he's sent and were published. I know everything about him. I know almost everything about him. And it only reinforced the conclusion I had reached in '77 when I started when he first came after Becker. It was after Becker. He didn't go after me until a few months later. That's when he went after me personally. But at this time, he's after Becker. Now, Becker ended the interview, came over and sat down. But some interview took place exactly where my electromagnetic paramagnetic resonance spectrometer was sitting. He came over and sat down, and he said, Marino, look for a new job. It's only a matter of time.
Whoa.
He knew what he had done.
Whoa.
He knew. If there was any room left for me to respect him more, that room got taken up. And of course, that's what's happened.
So he did I would assume, the risk-benefit analysis, and he thought that the people deserved to know the truth.
Precisely.
Yep.
Precisely.
So he basically was a martyr.
That's my word for it.
Yep. And
When I
how
wrote a book
long?
about him, I tried to make that point.
Yep.
I explicitly told this story and told about my impression, the consequences of it.
Wow. How long after the 60 Minutes interview did it take for things to start really going downhill?
Immediately.
Immediately.
Every NIH grant we had and every VA grant we had got canceled
Wow.
within 6 months, thanks to Jaffe and his tool, being the tool of Handler, who was the consultant to VA central office. But it turned out he was a consultant only to the biochemistry funded research. There was a whole line of research involving orthopedic surgery because that's important to the VA. Now, those folks liked Becker a lot. And those folks had money that they could spend and did not have to contact Handler for an opinion because he only judged biochemistry. So we got a 2-year grant, a lot of money, a 2-year grant to continue. We got that in a couple of months, and he said to me, Marino, what I said before still holds. Look for a job because this one's only going to last 2 years.
And so it was. And then, so what was your plan then at that point? What did you decide to, is that when you decided to move down to Louisiana?
Oh no! Because I had 2 years ahead of me,
Okay.
and you can't go looking for a job in 2 years. And I certainly wasn't going to leave prematurely. I told you this is the best job in the world.
Yep.
So I waited till they forced him out of the lab, and then even if they forced him out of the lab, the orthopedics people were still trying to keep the lab going by hiring one of Dr. Becker's students. He had fellows that came from the orthopedic department. They did their residency there, and they were in a patch on him. But at least it would have been a name to keep the lab going. At that time, we had three. I forget exactly the dates, but within that period of time, we had 3 PhDs in physics. We had 2 PhDs in biology. We had 3 or 4 technicians, and we had all the equipment and supplies we needed. That ain't bad. I wasn't going to walk away from that. So I figured I'd worry about it when it started to get bad. They actually forced him out. In December of '79. We had a going away party in January of 1980. But the possibility of keeping it going still existed. So I had breathing time, a minimum of 3 months, maybe as long as 6 months. The lab kept going. And I kept going, looking for jobs. Actually, I didn't have to leave. I was a tenured federal employee. They owed me the salary, and I was making good money. But they didn't owe me the job. They didn't have the lab open. So they looked around for every job at that institution, at VA hospital, which I was qualified for. And it turned out I was only qualified to be director of the hospital. That was the only job description that matched my job description.
Whoa.
So they offered me the job as assistant hospital director because their rules required you had to be an assistant hospital director before you became I wanted to be a hospital director about as much as you would like to cut off your arm, I said, up yours. It looked real hard. And thanks to the antagonism that Andy Bassett had generated in his funding from NASA, I got a visit from a resident from Shreveport, Louisiana, who liked me very much, whom I liked very much, And after visiting for 3 days, and he said, how would you like to come to Shreveport and work there? I said, Frank, you're just a damn resident. You can't hire a professor. What the hell are you talking about? I said, listen, do you want to come or not? He said, the guy who works there, who's the chairman of the department, is going to think you're great. He's going to want you there, and he's going to support you. I said, yes. 2 weeks later, I got an invitation from the chairman of the department to go down there for an interview. He liked me a lot. His wife liked me even more. By this time, my book, Becker and I wrote, called Electromagnetism and Life, had been published. She bought a copy, and she made it the mandatory book to be read by her book club, okay? I mean, whoa! Does it get any better than that? A lovely lady. When we got there, she showed us around. She made my wife feel. She made my wife feel at helm. She's a Yankee, if ever there was one. Her political leanings were different than it turned out that hers were. We were about as different night and day, but they just welcomed us. Merrily made my wife Lynn feel at home. And let me tell you something. This was a strange place, and we settled here in a strange location. I bought almost an antebellum house way out here in the country, and I moved into a village where I'm the only Catholic, Italian, lawyer, scientist, Yankee. None of them here. I had all five. I learned not to be as combative as I had to be in New York to survive, and I wanted to survive here, and I was very careful about what I said. And it started with getting along with the people who were going to sponsor me. So I took the job and came here.
And at what point, actually I have a couple questions before we get into your time in Louisiana, because there's a lot I want to talk about there too, but I want to make sure we talk about the development of your perspective over time on the role of like the government, the military, like just centralized power structures and controlling science, because I feel like given your experiences in Becker's lab, it must have, I mean, at least in my perspective, I would have started out as a naive grad student. And then over time, you kind of see like, oh, like we're not just doing like pure science here, like there's interests involved. So what was that like for you?
It wasn't too shocking because I had already gone to law school. And I see how law works.
Mm-hmm.
You know, on one hand, a lawyer has a legal obligation to do the best job he can for his client. I would certainly never dispute or argue against that. On the other hand, if his client is a company that makes cell phones, and there's a question about whether they cause brain cancer, he's going to go out looking for an expert to say it doesn't cause. So he calls Joe, and Joe says, well, I can't say that. Doesn't hire Joe. Tom, can you say that, Tom? Yeah. He keeps looking. Then he finally finds Ezekiel. And Ezekiel says, sure, I'll say it. But my fee is going to be X number of dollars. Now, the lawyer knows that the guy is doing it. He only wants to get a guy who can do it well. He doesn't want to get a guy who's ethical. So his ethics don't require him to hire an ethical guy. So it was only one step from that to realize that the scientists weren't ethical. That's how it went.
That makes perfect sense. So at what point in the timeline did you go to law school?
Got my PhD, 68, moved to the country, and had a baby. baby's 1 year old. Put him in his crib at night, and a stone quarry that's half a mile away sets off these enormous explosions, knocks the kid out of my kid out of his crib, and then the explosions lead to dust. If you go outside, you choke, and it's got this rumbling. When they sell the stone to make roads, they don't sell big hunks of stone that they expose by blasting. They sell small pebbles, which they generate by crushing, which makes ear-splitting noise. And then they put it in trucks that go right down my street, and the stones jumping off the back of the truck, bouncing against my plate glass window, which is my plate glass window happens to be not too far from the road.
Oh my God!
So I launched. I'm now a lawyer. I'm 1 year in. I passed the bar in New York. No, excuse me. This is before. This is just out of graduate school. I go. I don't know what the laws are. I don't know what the rules are. But there's something wrong about this. I go complaining to the town fathers where the quarry is, and they hold a hearing. And at the hearing, I'm ready now to tell them what the problem. I expect they're going to call on me and then ask me questions about it because I just sent a letter. Well, they never called on me. Right after the hearing began, I turn around and I see three guys in shirts, suits, well coiffed, followed by three more guys coiffed, not as Natalie, but still looking very intelligent. And then the first group, who turned out to be lawyers, started asking questions under oath of the other guys. So they put the one guy turns out to be an expert from North Carolina who specializes in measuring sound. He testifies under oath that he went on my property and made measurements of the sound levels, and they were no greater than the levels of chirping birds.
What?
And then another guy who's an expert at measuring vibrations in the ground, he testified that there are no vibrations, even when there was an explosion, that came onto my property. He set up his seismograph on my property and couldn't measure anything.
Oh my God!
And on it went. These guys, I call them scientists with a small s, okay, are testifying as experts about their version of the truth. That's what I learned. I had really learned it when I studied Nietzsche. Now I really saw it in action that there's no such thing as truth. There's only versions of the truth. I just went bizarre. I stood up. I started complaining. I didn't know what the rules were. I was making a fool of myself. And all I saw, I can remember, was the guy who was presiding going like this, pointing to the policeman, going like this, for the policeman to come up and grab me and throw me out of the hearing, which is what he did. 1 month later, I applied to law school. 1 month after that, 2 months after that, I was accepted. For the next 4 years, I went to law school. It takes 3 years normally to get a degree in law, but I was still working full-time in Dr. Becker's lab. He fronted for me. He arranged my tour of duty, it was called, so that I could go across the street to my law classes.
That's awesome.
I tell you, if there was one last item of non-respect that I had for him, it was gone. All right? I mean, how much more could a guy do? He was by that time a big shot. He felt he could do it safely, that I wasn't jeopardizing his job. Because I don't know what I would have done if he said, no, you can't do it. But he said, you can do it. So it took me 4 years. I graduated, got my degree. Got my degree. passed the New York bar just for kicks. I just didn't want to be able to be called an inferior lawyer I never intended to practice law, but I got it. The New York bar is a whiffy bar, but let me tell you, but I got it. That's how it started. I wanted to know what the rules were in anything I was taking part of. The worst thing in the world to me is to be playing in a game where I don't know the rules. That's why I went to law school. Now I know the rules. I never played again in a game where I didn't know the rules.
That's really important. And I think a lot of people in science should know the rules of the game, because I mean, then it's harder to get fooled, basically. And then you can also play back, you know?
It's a good rule for life if you're going to live life and be happy. If you're going to play in game X, learn the rules of game X. I went for the whole enchilada here. The rules of law govern everything. So I didn't just look for the rules of science or the rules of business or the rules of that. I looked for the rules, capital R. I figured I could always go down. I couldn't necessarily go up as time went by.
Mm-hmm.
But the principle is there, Alexis. It's there. If you're going to play in a game, if you're going to take part in a human endeavor, make sure you know the rules that govern the endeavor. Otherwise, your likelihood of being happy is compromised.
Mm-hmm. And so your time in law school and the perspective you gained there, how did that color your experience in Becker's lab? You could really see through like a lot of the corruption that was going on.
I could see, well, that puts it too starkly. I could see what people were doing, why they were doing it. I could see the constraints in which they did it. And a lot of times I sympathized with them, just like I sympathized with the individual we discussed a few moments ago in terms of what he does for a living. I try not to be judgmental about other people. I just want to be judgmental about me.
That's fair. That's very fair. So, okay, let's fast forward to Shreveport then. So you get down there, you're starting a lab. What's that process like? And what was the primary focus of your lab during your time there?
The primary focus from the day I started to the day I left was to continue along my life's path, which was to show that electromagnetic energy is biologically active. It has biological effects. That the stress response system is a plausible model for explaining how it can exacerbate and cause disease. It doesn't cause disease like communicable diseases, although it has a role in that. It doesn't cause communicable diseases. Then I wanted to get it metaphysically established that there were effects. Pushing back because I had the resources to do that, pushing back my enemies who said it was impossible by demonstrating biologically, according to the rules of biology, that there were effects. And the only logical conclusion is that it was caused by the electromagnetic energy. Now, I did that in 5 different animal systems. Now, having done that, I decided that there was no point to going any further in establishing it. They're on the record. If you're not going to believe it, you're not going to believe it. It's being opposed all the time. The bad guys, the guys at the Electric Power Research Institute, are hiring research for hire guys like Battelle, Pacific Northwest, to perform rigged studies. That's another whole story we're going to talk about some other time. At any rate, I wanted to do that and accomplish that certainly by the 90s, 92, 93, 94. Now I decided to determine how a human being detects them. You know, they can't cause effects in human beings if the human beings don't detect them. Well, we know how the human being detects light. We know how they detect sound. We know how they detect hearing, touch, taste, the sensory system in the body. The argument against me was there's no sensory system for detecting them. Well, my reply was, it's there, we just don't recognize it. So I went looking for it. The first place I wanted to find is where it was, what part of the body. So I did experiments with animals that I would expose animals, the whole body, to electromagnetic energy and show that they detected it. And by the way, I had to work out a parameter to show detection. I couldn't keep killing them, taking blood samples. It was way too expensive. So I invented a way. I'm going to measure the brain electrical activity. Now, if they're not detected, the brain electrical activity can't be changed by their presence. Well, how do you measure brain electrical activity? You measure the EEG. How do you analyze the EEG? Well, the way physicians analyze it is doing Fourier analysis and dividing it into frequency bands. Very, very, very primitive. Sufficient for physicians, but not for research. So I had to learn a method for analyzing EEGs to be able to detect their change. Enter recurrence analysis, a neat form of analysis for analyzing any nonlinear, chaotic signal in nature, including, but not limited to, EEGs. So I began human studies using recurrence analysis to analyze for the presence of EEGs and detecting and analyze and comparing them to the EEGs of the same person. The person has his own control without the presence of electromagnetic energy. And by the way, I had supported the idea that it was in the brain by doing results experiments with rabbits. Basically the last of my animal experiments, I would apply a magnetic field to the whole animal and show that the brain waves changed using recurrence analysis. This is before I did the human studies. It's a part of the requirements to show that what I was doing was safe. I had to go through a whole set of requirements. I won't go into those now. Then I applied the field just to the body of the animal, not to the brain. And when I applied it, the brain didn't change. The detector wasn't in the ass end of the rabbit.
Mm-hmm.
When I applied it to just the head, it changed. So I knew that reinforced the idea that it was a sensory system that was located in the head. Not just that it was a sensory system mediated by the brain. I took it one step further. So it's in the brain, my latest experiments were to directly verify that it was the sensory system was in the brain. But anyway, I spent the next 7 or 8 years exposing humans to simulated anthropogenic electromagnetic energy and proving that it altered the EEG, which means it was detected. After doing all these animal studies, after doing all these human studies, I was satisfied that I understood how the energy got into the body and where it got into the body. I didn't get it down to a specialized cell. There's a specialized cell for the eye. There's a specialized cell for all the other, but there's no specialized cells for some things like touch. Touch is mediated by free nerve endings. It's not an organ and it's not a special cell.
Mm-hmm.
So I was really happy. Everything is, but I lacked one thing. There still existed in the world these clowns. They were genetic inferior physicists, genetically inferior to Hermann Schwann, who's a guy I'll have to talk to you about all by himself. I'll talk to you about him later. His argument was that electromagnetic fields can only affect living things by heat. I wanted to prove that was wrong, and I did. He also wanted to say that the levels of energy that penetrate the skin are below the levels of KT, the randomization forces in the body. I published simple, straightforward biophysical calculations which showed both of those ideas were dead wrong. What else is there for me to do? I've done everything I started out in life.
Yeah, makes perfect sense. And yet somehow during this time, I mean, you've seen the rollout of cell phones and cell towers, Bluetooth, Wi-Fi, 5G towers, everything is getting even more high powered. And like, what has that experience been like? Is it frustrating, or are you hopeful?
I'm not hopeful until the science that Philip handled up this goes away.
Yeah.
And that didn't happen in the 20th century, and it shows no signs of happening in the 21st century. I'm writing my book for the 22nd century so people can understand how science got into the bloody mess it's in now. Bloody mess. I'm not hopeful at all. All I want to do, I mean, eternity is right over there. I mean, I'm 83 years old. How much more can I go? It's right over there. I just want to enjoy life, enjoy my kids. They're the greatest people on earth. They come home for 2 weeks a year, and it's the highlight of my wife's life and I. We're both in good health. I just want to continue enjoying it. I'm not, and besides the way, since I understand the big system, I understand the role of economics. How can I get pissed off at guys wanting to do it? Number one, because they like it, because it's fun, and they're going to use the phone. And number two, it helps fund jobs for people, so people can put food on the table for their family. I mean, I get it. You know, all I do is practice the advice that I preach. I just minimize the stressors. It's not a specific cause of disease like infectious disease. It's a stressor. It taxes the pituitary adrenal axis, which taxes the body's immune system, which makes it less effective. Things that the body would ordinarily prevent you from developing a disease don't work. The disease comes, so you get cancer, or you get any one of myriad chronic diseases. You can't turn back the book, the clock, and I certainly don't want to. I just minimize stuff. For years, I used Ethernet cord. I didn't have Wi-Fi. There was needless exposure. Ethernet was better than Wi-Fi. But lately, as the number of devices proliferated in my house, it got to be a pain in the ass. So now I don't just turn it on when my kids come home for 2 weeks a year. I turn it on all the time, realizing that the field I get, less than 1 microwatt per square centimeter, is a patch on what everybody else in the world is getting. I said, what the hell? You know, I'll cut down on stressors someplace else. I don't eat the preservatives in food. I cut down on other stressors and give it a little bit on this one. That's the reason I have this nice, convenient contact with you today via Wi-Fi.
Yeah.
I understand the rules. I understand the society I'm in. I don't get mad.
That makes sense. I mean, there's a lot of perks to using the technology for sure. I mean,
would you want to do without electricity? I'd go a long way. I feel a little bit in the condition that the football players are. They know they're going to get concussed. They know they're going to get a CTE. They know they're going to be walking vegetables when they're 60 and be pushed around in wheelchairs and not recognize their wife or their kids. But hey, right now they're getting $30 million a year and life is great. And then they say, I know that's coming. I hear about all this. I still want it. That's the way human beings are. They know the rules, at least to that extent. And they make their decision. Now, I don't want anybody making decisions for me. And I don't want to have to make decisions for anybody else.
Yeah, I think that's a good analogy. I guess my biggest point of frustration is that I feel like I truly believe in like the ingenuity and creativity of humans, and if we were to just acknowledge the issues at hand, I feel like we could use our creativity to find ways to use technology that's safer. But when we're in the midst of denying that it's a problem to begin with, I feel like that's the biggest issue.
You're right. That's exactly what I tried to say, but maybe not as eloquently and as concise as you did. But that's exactly right. If that's what I meant when I said I don't want to be making decisions for anybody else, unless it's so acute and it's so far from something you know about. Telling you, for example, that that you shouldn't ingest mercury. I mean, you need to be told that. I mean, even though it's me telling you, the me being Uncle Sam, he needs to tell you that. But at a minimum, Uncle Sam should ensure that the information is available. And Uncle Sam should not become part of the problem. When the FDA says that there's no evidence that cell phones cause brain cancer, that's just simply not true. The FDA is in many cases part of the problem and becoming increasingly more part of the problem because becoming more increasingly capitalistic. And the guys who invest in venture capitals want to make money, and they are citizens too, and they hire lobbyists, and the lobbyists work boom, 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 boom.
Yep, it's an entire incentive structure that needs to kind of go down. And honestly, your bringing up Handler, I think, is a really good example for people of how even just one individual can completely change the timeline and the course of history.
It depends. It's all a matter of timing. He comes along just after World War II. Just after World War II. In fact, I take it back. He comes along before World War II. He winds up teaching biochemistry at Duke University in 1939.
Wow.
He gets a deduction, so he stays there, okay? Everybody else goes to war. He stays there. We build a bomb. We see how incredibly intelligent physicists are, how they saved us by building the bomb. The money available for physics research goes off the top of the charts. And physicists become gods. You know, I come to maturity at about that time in the 50s. I want to be a god like them and predict the future. They know they can predict the future. They know the 4 laws that govern inanimate reality, and they know them, and they can predict what's going to happen. How much more powerful in life can you be? That's why I wanted to study physics. I didn't know that physics is how you got there. When the satellite went up, I wrote letters to famous physicists who were interviewed in the paper. And I said, what do you study in college if you want to study to learn that? They said, study physics. Physics was really great then. He comes along with to put it mildly, a silver tongue. He talks in an oratorical way that would have made Demosthenes jealous. And he uses big words. He uses wonderful literary tropes. He's an intelligent guy. As I say, he got his PhD when he was 21.
Wow.
Got his PhD when he was 21. He was home educated. Nobody could take care of him at school. I mean, he's a polymath, but he becomes a scientific biochemist. Biochemistry is the solution to all the world's problems. That's the ideology he's born into. And he writes a book. You ought to sometimes take a look at it, The Future of Man. It came out just in '68. And it showed the powers in science in this country, what a spokesman this man was for science. And I might also tell you, between 1962 and 1968, he created a National Institute of Health,
Wow.
For general medicals, NIGHS, whatever it is. He founded it. He went before Congress 2 years in a row, convinced them to get it started. Him alone. Before that, he spent years being the chairman of the committee at NIH that funds research. Do you think guys like Becker, who were not utter believers in reductionism, got $1? No. He controlled the money. He controlled the institution. Then he gets appointed as the head of NSF. Now, there's a dude with a lot of authority. What he said went. And by the time people caught up with him, 1972, 1973, the damage to science was done. And it can't be undone until people understand how it got done. That's what my book's going to be about.
When can we expect your book?
I think I'm about 6 to 7 months away. But again, from publishing it. But again, I'm concerned about eternity right over there. So what I'm doing is I'm putting each chapter in online. It's rough. It's not integrated. It's got defects. But it's a lot better than nothing, and it will survive. Now, I just have to get chapter 10, which is the pits for him. That's when he really wigs out. That's when he's really kicked in the ass. I'm just maybe a month or 6 weeks away from publishing that. It will be a little more polished than the other ones because I'm getting better at what I'm doing. But it won't be the last 2 chapters where my personal interactions with him, and they're going to come down quickly. I've already written about them. They just have to be integrated into separate chapters and integrated into the book. So when I get to chapter 10, the guts of my message will be done. To make it a nice read, you're going to have to wait probably the better part of 2025 and hope eternity holds its breath.
Well, it seems like you're doing everything right and, healthy and having a happy family and a nice home. And
right.
So
minimizing stresses.
That's it. I'm so excited about that book. So where can people find the chapters that you've been publishing as you go? What
everything I've ever written is on my website.
Oh, great.
Every article, every neurology grand rounds, every orthopedic grand rounds, every talk I ever gave at a society meeting, everything.
Perfect.
Every failed business. I was the president of a company. Did a clinical study trying to create an artificial anterior ligament in the knee, but failed. I took all of my venture capital investors down with me, the best I could. It turns out I'm not a very good businessman, but the science I did was not bad.
Wow, awesome. And what's the website called?
AndrewRayMarino.com.
Great. I'm going to put it in the show notes so people can find it.
Hope so.
I will, yeah. People will
love I've been on this podcast.
Oh yeah, people will love to read about it. And so how many books have you written total?
That'll be the fifth one, the one that comes out. Four in print, and that'll be the fifth. And if eternity still stays away, it won't be the last because I got other ideas. But I got to get this one done.
Yeah, it seems like it's a really important one. I have to say, I love your writing too. I feel like it's very personable. It's comedic. It's just like Going Somewhere is a great read. I would highly recommend people to read it. I think it balances like the science with the personal story and how it weaves together. And I think it's so important because oftentimes in science, science is very disembodied and we're very mechanistic and just detached from reality. But I feel like when you write, you're really weaving everything together in a way that's digestible for people.
You have to know the rules, and I know that rule. And it started that way. It's exactly right.
Yeah, that's it. Well, I mean, we've had a great conversation. I think we've gone about an hour and a half. We could probably
Yes.
keep going, but like, what
I'm
we should
running out of
probably,
energy if you want to know the truth.
what is it?
I'm running out of energy.
Oh, I totally understand. So I think what we should do is, if you're up for it, when your book comes out next year, maybe you should come back on and we can talk about the book.
We'll see.
I think that would be great. All right. Well, thank you so much for your time, Dr. Marino. I think this was a really, really great episode. People will be super interested to go and read what you're publishing online and your other books that are already in print. And I just want to really, really thank you for your time. This was a very special episode for me. I just really love your work and Dr. Becker's work. So it was a real treat.
I have two questions for you. Number
Yeah.
one, when am I going to get a copy?
Today, I'll send it over.
Okay. Okay. I meant to ask you for permission to record it here. I
Of
didn't do
course.
that.
Yeah.
Well, it's too late now. It's
Oh.
over. So
Oh.
you're going to have to depend on you sending it.
Sure. No, I'll send it over today.
And then you are going to, how will I get it? It's going to be too big to send by. How will you get it to me?
Yeah, so I can send you a Google Drive link.
Yeah.
That works.
Okay.
Yep.
It's going to be an MP4 file, I take it.
Yeah, I can send you both if you want the MP3 and the MP4. I can send both.
Let's do that.
Yep, I'll do that.
And then you're going to put an edited version on YouTube and Spotify and everything else.
Yep.
Will you send me the links to that when those are out?
Of course I will. Yes, I will send you an email with the links to Spotify and YouTube and yes, everything you need to access it, and we'll take care of you.
That was my first question. My second question is, what is your last name?
Cowan. Cowan.
What was that other name I saw?
Oh, Jasmine.
Yeah.
It's my middle name.
Jasmine, your middle name. I see. Okay. All right. Okay.
Yep. That's my middle name.
Great talking with you, kiddo. I enjoyed it.
Yeah, likewise. This was really fun. Thank you so much again for your time. And I hope you have a great day.
Okay. Bye-bye.
Bye.